Okay, this is the first problem that we're going to look at in 10.1, and it says 54 wild bears are anesthetized and then their weight and chest size were measured and listed in the data sets. Results are shown in the accompanying display. Is there sufficient evidence to support the claim that there is linear correlation between the weights of bears and their chest size? When measuring an anesthetized bear, it is easier to measure chest size than weight. If so, does it appear that a measured chest size can be used to predict the weight? Well, this little symbol right here is called rho. It looks kind of like P, and you're kind of talking about the population with it. As always, we kind of let equal, and we're going to be 0 because we want to know whether it differs. We're not trying to think if it's a lot less or a lot more, so we just want to let it equal 0 and not equal 0 for the alternative. Okay, we're reading from this chart is really what we're doing. It says identify the correlation coefficient R. Okay, that's this part up here. And they want it to 3 decimal places. This 9 rounds that up. So that's 0.952. Okay, then it says identify the critical values. Okay, since it's not equal to, we're talking 2 tails, so we've got 2 critical values, and those are our critical values, and we want these to 3 decimal places also. So that's 0.268. Okay, is there sufficient evidence to support the claim that the linear correlation between the weights of bears and their chest size? Choose the correct answer below. All right, so they gave you the critical R here, and they've given you the correlation coefficient. You want your correlation R, the absolute value of it, to be greater than the critical one. The absolute, keep in mind, it's absolute value here. So is there enough correlation? Well, 0.9 is a lot higher than 0.2 something. So yes, because the absolute value of the test statistic exceeds the critical value. So yes, what is the critical value? What's the critical value here? What are they asking for? The critical value? They're asking for the test statistic, because the absolute value of the test statistic, they want the test statistic. The test statistic is this correlation coefficient R that you found right here. So that's 0.952. Okay, when measuring an anesthetized bear, is it easier to measure the chest size than the weight? If so, does it appear that the measured chest size can be used to predict the weight? Well, we had very good correlation, so that means it's good. So yes, it's easier to measure the chest size than the weight, because measuring the weight would require lifting the bear onto the scales. The chest size could be used to predict the weight because there is linear correlation between the two. Now you might go on down. That one says not linear correlation with a yes. And the last one said it was too much variance. So yes, there is good linear correlation. That's what we were looking for. Okay, that completes this first problem.